अच्छा
power we get from the third rail.
No, the power we are getting from the batteries.
There's no power. The rail is passive.
Then why do we need the third rail?
That is for the linear induction. So it assists. And fortunately we got Dr. Shinde, who is an outstanding scientist. He's an Indian specialist in electromagnetism. He's run from Japan. So these things we do from heart. Now that they found that we are catching up, they have started denying that technology to us. They increase the price by 100%. So now we're localizing.
So we'll just show a demo of these two.
What is it?
levitating.
It's a simple time. We wanted time and validation. It is a simple 0 to 800 easy. No, it's available. I can do it, but we wanted it.
Companies you will have.
We have already. Yeah, we are getting.
Actually, we are having issues with the control to converters. So these two will be levitating. So you can take that slowly down.
रोहित फ्रेम बनाते रहो
Now the wheel is rotating. So once it slowly flips up, we can rotate the wheel.
How much magnetic gradient have we designed?
7 mm. No,
5 mm.
5 mm is what I'll get this 5 mm. It's okay.
கொஞ்சம் இங்க இருந்து வெளில நிறுத்துவோம். ஓகே
Super.
Yay!
T-shirt.
So with
Very good. Very good. Thank you. Thank you. Thank you. Thank you. To be here.
I wish I could stay in IIT Madras.
So now we demonstrate a product.
Yeah. Sir, one picture.
All the safety you can, I think, take cover under the
Okay. I'll stand here only. Yeah. என்னப்பா எல்லாம் அந்த பக்கம் போக கூடாது, அங்க நல்லா போகுது. இல்ல ரொம்ப பக்கத்துல நிக்க வேண்டாம்.
கோனுக்கு வெளியில கொஞ்சம் முன்னாடி போங்க. எங்க தோணே தான் கோஆபரேட் பண்ணுங்க.
பிரதர் சைடுல வந்து பிரதர்.
यादव जी,
Minister is going to see us.
भाई सीताराम,
इधर चले जाइए, इधर चले जाइए, वहाँ खड़े हो जाइए। पता ही नहीं चला कैसा। और आगे चले जाइए। पीछे आ जाओ, पीछे आ जाओ ब्रदर, पीछे आ जाओ। साइड साइड पीछे आ जाओ। आप तो यहाँ करना है, वो आ जाओ। रेडी।
भाई पीछे आ जाओ,
हट जाओ, आगे बताओ।
हाँ पीछे पीछे।
ये दो मोबाइल बोल दीजिए एक बार। कल नहीं छीन लिया जाएगा। ये क्या आगे उड़ रही है।
यहाँ पर एक और चीज जो पॉड है, पॉड प्रोजेक्ट में इस तरीके का पॉड बनाया गया है। साथ ही साथ यहाँ पर अलग अलग
everybody is there in the
everybody is inside the pod.
கொஞ்சம் முன்ன.
Meanwhile, you give the other one. We have another application where all engineering 3D CAD models. Can you move out of this?
Little bit.
Can you see it?
இல்ல கொஞ்சம் ஸ்பேஸ் இருந்தா தான் உங்களால பார்க்க முடியுங்களா? கொஞ்சம் பின்னாடி கொஞ்சம் வழி விட்டுக்கோ
சார். கேசல் சார் அங்க இருந்து தெரியாது.
கொஞ்சம் பின்னாடி ஒர்க் ஆகும். கொஞ்சம் பின்னாடி
That's working now. This is working now.
Don't clash with them. Don't get listed. Yes. Are you into this?
Is it working?
Partially. Hey, you're not going into this space, right?
pod is moving except for the ticker leaf.
So this interior we designed.
Right, very nice.
This is made with the actual CAD model of the car. Not just an image.
On the left hand side, you can see
Sceneries and stops. Jaipur, a passenger will actually come.
very nice. Very good.
வருதா ப்ரோ
Excellent. Super.
This is the visualization.
எது ஆமா ஆமா அதுதான் அதுதான்
Yes, yes. यहाँ आप देख खुद रेल मंत्री अश्विनी वैष्णव इस तकनीक को कहीं न कहीं मुआयना कर रहे हैं, समझने की कोशिश कर रहे हैं कि आखिरकार जो भारत का भविष्य है वो किस डायरेक्शन में जाएगा। तो यहाँ हम सीधा खुद रेल मंत्री से भी बात करने की कोशिश करेंगे, क्योंकि यहाँ जब हम इस तरीके की तकनीक की बात करते हैं आविष्कार स्टूडेंट्स कही जा रही है और भविष्य का उत्साह है वो आप देख सकते हैं आईआईटी चेन्नई के अंदर। तो आईआईटी चेन्नई में कहीं न कहीं देश का नाम रोशन किया है। हम आपको खासतौर पर छात्रों में या यहाँ पे जो टिपिकल लोग हैं उनके अंदर और यहाँ पर देखिए किस तरीके से सेल्फी ली जा रही है और एक नया इतिहास लिखा जा रहा है, क्योंकि जब आने वाले दिनों की अगर हम बात करेंगे तो यह सिर्फ टेस्ट ट्रैक नहीं रह जाएगा। देश के अलग अलग हिस्सों में इसी तरीके का ट्रैक बिछेगा जिसके अंदर वैक्यूम में कहीं न कहीं ट्रेन चलेगी। और वैक्यूम में चलने का फायदा ये होता है घर्षण नहीं होता है, और घर्षण न होने का मतलब है आप अच्छी खासी स्पीड अक्वायर कर सकते हैं। तो एक बड़ी स्पीड कहीं न कहीं हासिल करने की बात है। एक तरफ बुलेट ट्रेन की बात हो रही है तो दूसरी तरफ हाइपर लूप की बात हो रही है, और इन दोनों का कॉम्बिनेशन कहीं न कहीं देश को बहुत आगे ले जाएगा। यहाँ को दिखा रहे हैं कि किस तरीके से यह ट्रैक बनाया गया है। और खासतौर पर अगर हम बात करें
थोड़ा पीछे हो जाओ ना सर बंदी पीछे हो जाओ लिटिल बिट बैक। आप लोगों को थोड़ा पीछे होना पड़ेगा। फ्रेम में ये ले लो, दोनों ले लो, ये भी ले लो और वो भी ले लो।
सर ये नहीं आ पाएगा सर,
थोड़ा पीछे हो जाओ ना,
थोड़ा पीछे हो जाओ। अगेंस्ट लाइट है इसलिए दिक्कत आएगी। अगेंस्ट लाइट
सनलाइट वैसी है इसलिए।
ऐसे इतना में
ठीक है
सर ये कितनी बड़ी उपलब्धि है जो आप लोग के
ट्रांसपोर्ट सेक्टर में बहुत सारे नए चेंजेस आ रहे हैं। ट्रांसपोर्ट सेक्टर में एक बहुत बड़ा नया इन्वेंशन संभव है, वो है हाइपरलूप। हाइपरलूप पे काम करने के लिए यहाँ पर आईआईटी मद्रास में एक यंग इंजीनियर्स की टीम है, उसको रेलवे की तरफ से और इंडस्ट्री की तरफ से सपोर्ट किया जा रहा है जिससे कि नए तरह के एक्सपेरिमेंट्स हो सके। ये पूरा हाइपरलूप जो बनाया है 410 मीटर्स का ये पॉड है। ये पॉड इसके अंदर चलता है और वैक्यूम जब क्रिएट हो जाएगा तो ये पॉड मैग्नेटिक लेविटेशन यानी ट्रैक के ऊपर नहीं चलेगा, ट्रैक से ऊपर उठ के चलेगा। इस तरह का इसका एक्सपेरिमेंटेशन हो रहा है। काफी अभी जर्नी बाकी है, अभी एक्सपेरिमेंटल स्टेज पे है और रेलवे की तरफ से पूरा सपोर्ट है, इंडस्ट्री की तरफ से पूरा सपोर्ट है, भारत सरकार की तरफ से पूरा सपोर्ट है। जैसा आप जानते हैं प्रधानमंत्री श्री नरेंद्र मोदी जी हमेशा इनोवेशन पे जोर देते हैं। टेक्नोलॉजिकल इनोवेशन पे जोर देने के कारण इतना बड़ा स्टार्टअप का इकोसिस्टम बनाया है मोदी जी ने। ये उसी थॉट प्रोसेस का, उसी फिलॉसफी का हिस्सा है कि मोदी जी की इस थॉट प्रोसेस के कारण आईआईटी मद्रास में एजुकेशन मिनिस्ट्री के हेल्प से, रेलवे मिनिस्ट्री की हेल्प से, सबकी हेल्प से, इंडस्ट्री की हेल्प से सब मिलके इतना बड़ा एक एक्सपेरिमेंट कर पा रहे हैं। इसमें नेक्स्ट स्टेप होगा प्रॉपरली पॉड को अंदर के स्ट्रक्चरल सब सेटअप्स ठीक करके अंदर चलाने का। दूसरा, जितनी इलेक्ट्रॉनिक्स है वो आज मैंने जनरल मैनेजर आईसीएफ साहब को बोला है, सारी इलेक्ट्रॉनिक्स जो वंदे भारत में और दूसरी ट्रेन्स में लगती है वैसी वैसी हाई क्वालिटी की इलेक्ट्रॉनिक्स यहाँ के लिए बनाए तो ओवरऑल एक बहुत अच्छा इकोसिस्टम बन सकता है। तो आने वाले भविष्य में हाइपरलूप एक रियलिटी बनेगा। इंग्लिश में फ्रेंड्स, एज यू नो, our Prime Minister Shri Narendra Modi ji has always put huge emphasis on innovation. Here at IIT Madras, one major experiment, one major project has been taken up by some of the young engineers and the professors for developing a new hyperloop. Hyperloop basically is like a tube, and this tube will operate, there will be a vacuum inside the tube, and the pod which will operate inside the tube, that will operate in a levitation mode, which means there will be magnetic fields which raise the pod over and above the tracks. It doesn't move on the track, it basically goes up then moves. That is the principle of hyperloop. This is at this point of time experimental stage, but very good results are visible now. I congratulate the team of IIT Madras and Avishkar for doing this experiment. I also thank so many industry partners who have participated in this entire thing. I thank the Education Minister, Honorable Shri Dharmendra Pradhan ji, and I thank our Honorable Prime Minister Shri Narendra Modi ji for such big encouragement to this experiment. From Railways, we have been supporting this project for some time through funding as well as through technology, and today we have decided that the entire electronics of this thing, this project, will be developed in ICF Chennai. ICF Chennai is very strong electronics team because they are developing very large electronics, large power electronics for Vande Bharat and many other train sets and engines. So they are capable of designing new smaller electronics which are required for this pod. This is the pod, and this pod basically will be the transporting mechanism, and this tube will be the transportation medium. That is the principle on which it will work. This is a good experiment showing good results now. Maybe in a few years from now we should have a good working model. This point of time, this is one of the largest, longest tubes in the world. In Asia. This is one of the longest tubes in Asia. 400 will become the longest. Another 40 meters will become the longest. Right now it is 410 meters. 410 meters. Another 40 meters will be added. Then it will become the longest in the world. So this is a good experiment, and I thank Professor Kamakoti sir, Professor Chakravarti sir, and all the young engineers. Guys, come over. Come. Team Avishkar, come. Come. This young team. Come. Come this side. Come, half of you. Half this side. Come. I congratulate this young team for putting so much energy in this. Give them a big shout out. Good. Excellent. Well done, man.
Thank you so much.
Well done. Well done. Good. Very good. Excellent.
Please come, sir.
Good, man. Excellent.
Thank you, sir.
Very good. Well done.
Thank you, sir.
Super. Thank you, friends. तो थोड़ा ढंग से जगह सेट करो सर. हाउ यू होप दिस प्रोजेक्ट जगह सेट नेक्स्ट दिस वे सर क्या समाचार ये कैसे और भाई
संजीटर इंक पात्र हाँ सर உள்ளே எதுக்கு போனாரு
அதுவும் வந்து தண்ணிக்குள்ள வச்சு ஓடிக்கிட்டு
என்ன இது எல்லாருக்கும் வித்தியாசமா இருக்குங்க ஸ்டாண்ட் எங்க இருக்கட்டும்
Good morning. Today we are proud to host for the 72nd renewal of Team Avishkar Network together. Along with our esteemed director, our faculty, and other responsibilities. So, in this presentation, we wanted to give you a brief view about whatever technologies that you have witnessed outside and whatever innovative stuff is happening inside.
Now getting used to it, sir. I don't feel any difference nowadays, sir. Public spaces have to be practiced. Yes.
This is the next generation one. This is the next generation one. So actually we are testing levitation on this. So since we are having some structural issues on the inside, right? So we have started those tests. Once we fix the structure inside and we test everything outside, then we will move. We are planning to move inside. I can show that. So yes.
You can see the video.
Yes, sir. So this is the linear induction motor that is
நான் எங்க வச்சிருக்கேன் பாரு.
that is the electromagnet. So that is
That is for the vertical.
So that is for the
CO2 removal and odor generation. Next is our most efficient propulsion system yet, which consists of a yet to be patented technology which incorporates two motors into one. Third is low pressure boiler. For thermal injection, we can't use traditional methods as there is a vacuum inside. So for that, we use low pressure environment which is present in the tube to inject heat. Last is our integrated power electronics, where we can claim that we have created the largest power electronics PCB yet to be made in IIT Madras. Thank you.
Now, when we look onto the long-term goals, so like having built and designed the 422 meter tube, now we realize that there is yet more to infrastructure. Like by reducing the cost, we can further scale up the infrastructure. So we found out 3 ways by which we can do this. So first is the air locks. So air locks is basically wherein we isolate a section of a tube and pressurize and depressurize only that section. So the time required and the energy that is used is less, hence it reduces the total cost. And we have also filed a patent for this. So the second is the material of the tube. So currently we have a steel tube and we are going to go with the concrete tube, which will further reduce the cost by 84%. So next is the docking, which will help us embark and disembark passengers from the pod outside of the station, which will again help reduce the energy required and the time, and it's more energy efficient. One special development that we are working on is the real life mock-up cabin, which will help people gain real life immersive experience, like how Hyperloop travel would look like. Like we can proudly announce that we participated in the India's first global Hyperloop competition in GFC in February, and we demonstrated our pod 6.0. This year we will also be participating in European Hyperloop Week, which will be held in Groningen, and where we plan to demonstrate our pod 8.0. So these are the ones. Thanks. Pass on to Hari.
Hello sir, myself Hari. So I am part of Tutor Hyperloop. So initially I was back then in 2020 I was member of Avishkar, then I moved to the startup Tutor. So in Tutor our aim is to actually commercialize the technologies that was developed in Avishkar and see what are the useful use cases for it and develop it. So we have segregated technology into 3 major parts. So initially it will start with linear induction motor. For all the applications that require 200 km per hour, we will be going ahead with only linear motor based propulsion. Then for the applications that require 200 to 400, then we will be moving on to a maglev plus linear motion based technology. And then for passenger transport at the end of the day, we will be moving into a vacuum tube as well. So that's when the real Hyperloop will start. So in Avishkar actually when we started back in 2020 we have made 2 generations of linear induction motors. So starting from a 60 kilopod pod to a 100 kilopod, and now in Tutor we have developed a 150 kilometer per hour 1500 ton pod. So what we have done is we have modularized the motors. So if we want to add more weights, we can go up to 20 to 40 tons. We have to just add the number of motors. So we feel we are robust enough now to move to any commercial application with linear induction motors. So regarding the power electronics, we have been importing power electronics for the past 1 year, and we have got everything working, including the limitation that you saw now. But recently we have been facing some supply chain issues. So we are planning to move to an Atmanirbhar Bharat initiative where we want to develop all the power electronics. Yes, sir. Thank you. Levitation technology that we have developed, so that is what we have shown you here. So as of now we have been able to levitate all the 4 wheels statically, but this is where you see by doing dynamic levitation we are observing vibrations on the track. So we want to fix these issues and we have to take it as a learning and improve so that we can achieve dynamic levitation in the future. So these are some of the learnings that we have had on the way. So where we are doing precise air gap control and we want to do in-house power electronic modules, and we are also planning to make a track where it can take a load up to 40 tons. Yeah, thank you. Next, pass it on.
So we have developed three generations of part. In the first generation part, we showed linear propulsion. We took an Ashok Leyland dose chassis and then modified it for our use cases. But then we faced lot of issues when we took some other chassis design for some other purpose. So we made a ground up design and we created one chassis for on our own. So this is Gen 1 is the chassis which we decided on our own. It is a skateboard chassis which brings the CG down. So during dynamic levitation we will have less load transfer. And we have now done Gen 2 part in which we use for the levitation over there. So here it will have vacuum operation along with magnetic levitation. So for us we have all the subsystems are designed for full scale, so they will act as a payload. And then we have made it modular so that in case we have to replace some other part, it's just easy. We just to remove the bolt and then add it from the bottom. And we have brought the floor very down so that CG height is very less. And we have a top hat. So when during non-vacuum applications, in order to reduce drag, we use the top hat. So we got inspired by Falcon. That's also Indian name for Falcon called Garuda. That's why we named the part Garuda Vahan. And we had help from ANSYS in doing simulations, and we were able to reduce the drag up to a very good amount. And then we took Ashok Leyland's design studio help to come up with the front fascia for our top hat, and also with Katya's help in bringing the shape. We are currently having steel wheels and solid rubber tires in order to have lesser reflection during full load. And initially we had a pneumatic brake, now we have gone with an electric brake. So this is the second redundant brake. First one would be from the motor. In case if that fails, then we go with friction. And we also have brakes. These are a passive form of lateral control. We are now working on a lateral gear. So we are also making the part compatible for operation in vacuum. So this is the first chamber which we have made with the help of E-line. And this is the 8.6 kilo tube which we have in diameter. So we first test first chamber in this, do static testing here, and then only for dynamic testing we will come to the 410 meter part. So we had a lot of learnings from this journey of more than 2 years. So we had track vibrations. So we used the TMT to reduce the track vibration, which was successful in reducing the amplitude, but still it was not up to the level we want, control system wanted. So we are actually finding ways in which you can reduce the amplitude more. And the pressure chamber currently is having small leaks, which we will cut in the few weeks, and then we will be able to show this operation.
Hello, good afternoon. I'm digital and vertical from India. So, as the name indicates, digital twin is a virtual copy of any physical object with all its CAD designs and further all the physical characteristics, parameters, along with the live data feed from all the sensors and components. So, why is this important? Is because for any critical infrastructure, important infrastructure like smart buildings or cities and transport operations, using the concept of digital twin, we'll be able to optimize the capacity, optimize the operational cost, improve the safety, improve the customer experience, and improve the lessen the time needed to actually bring out further improved versions of the objects. So what we have done is we have optimized the core, the architecture to levitation, linear propulsion, and we have actually optimized the architecture for digital twin also, so that for any real-world problem that the railways has or any other transport system has, we will actually deploy only the respective layer of architecture which is in that. So depending on the use case, even the level of architecture that is actually needed. So basically, we have got some good support from ANSYS and so here. Using their support, we have actually built the mini digital twin application. We have taken a sample, cargo port operation from Chennai port to Madurai, and we have actually demonstrated how the port can actually take cargo and then take it to the inland terminal with various real-time monitoring of these systems. And this uses real-time CAD model and thermal and physical analysis of the battery system that we are actually using on the part. So this is So moving on. So we have also been interacting with a lot of railway officials and doing other secondary research. We have identified certain important use cases that we could actually solve using digital twin for the railways. So some of these we have listed here. you'd be very happy to actually use the services of Kollywood Cinema and then talk to them and actually identify specific use cases and take it up for the solution. This is the kind of the timeline that we have actually got involved in this digital win. We've submitted proposals and had reviews with Kollywood Cinema team. They have been pretty supportive. What we would like to do is actually get the main proposal approved and then probably take up a specific problem for solving. Okay. And this is the VR demo that we actually have. We actually saw the journey and this.
Good afternoon, sir. So you saw all IITs. I am a product of Indian Railways, alumni of the founding batch of Gati Shakti Vishwavidyalaya. Why we are different from others? So everyone's heard Virgin has failed, other Anglo companies has failed. What makes us different? Our initial focus is on cargo, area where the government is focusing a lot. We did the technology modularization like our colleagues talked. We did linear propulsion, maglev and vacuum, which gives us users for each case within India. Ports, airports, I'll talk about in the next slide. We have scalable infrastructure. Like you saw outside the tube, we can use the same infrastructure for linear propulsion, maglev and the same infrastructure for vacuum. Not necessarily we need the tube for doing the first two technologies, but once we have to go above 600, we take the tube. Now, this is one of a very unique approach, consortium approach. We thought we don't want to do this alone. We are taking all academia, industry, government together with us. We have Answers, Dassault, L&T and Railways. Customer inspired application, I'll talk about it in the next slide. Frugal engineering, this is one of the top applications that we have advantages in India. So this is our aim to achieve a full stack passenger technology stack by the end of next year. This is the consortium approach that we are planning to take with industry partners, academia and the government. So these are some of the projects which we are going to launch soon as for the commercial aim. Railway board, PET sir has been very supportive in this aim. By next month we plan to launch Kolkata Metro, Nilgiri Mountains Railway Project. Container Corporation of India has been kind enough to give us one whole yard to automate that and digital twin. These are some of the other potential cases we are in discussion with. Can you go on next slide? Okay, so DFCCI, right, all railway PSUs have been kind enough to invite us and give their whole backyard to do whatever we want to do. Again, coming to the state government. So this is an ask that we want from you, sir. IIT director has been kind enough to give us in principle approval to create a track around the tube, like 1 kilometer loop. We interacted with army, we interacted with all potential transportation holders and we found out this can be a base that we can make it in India and make it for the world. So we would love if you would support us in this project to make a whole loop around the tube. So that is all from my end. Thank you.
We at the EPA company are designing India's first flying air taxi led by Professor Satya Chakravarti. This is supposed to commercialize by December 2026. This eVTOL that you're seeing here is our flagship product called the E200X. It can carry 3 packs, that is 1 pilot and 2 passengers, and can cover a total range of 110 kilometers in a single charge. Right? So this aircraft has various use cases from passenger to cargo. Our very first go-to-market use case is as an air ambulance. We have an order book of 788 air ambulances, one for each district in India from this organization called ICAP. Here are the key use cases for the Indian Railways: disaster response, rapid medical evacuation, air ambulance, remote area maintenance, crew transportation, and delivery of critical spares or tools. Next one. Okay, so at EPA, each aircraft is designed with utmost safety in mind. In case of failure, the aircraft is built with 5 levels of redundancies. We are currently in the process of building our very first prototype. As far as the regulatory landscape of the aircraft. Thank you.
I thought you guys spoke to you about the eVTOL. This is a manned aircraft. So before we actually started designing the aircraft, we built different cruise vehicles here for our own tests. Right? So these are what we today call drones. So some of these vehicles that we built in the past, we have a lot of applications built on them to sort of push edge computing to industrial use cases. Right? We were early looking at combining RGB plus IR streams and pushing analytics to the end. Now, industrial use cases were for inspection and surveillance. We want to bring this capability to the railways. We work with the RDSO and the Southern headquarters to now come up with about 9 use cases. We go to the next slide. These are the 9 use cases that we picked up specifically for the overhead equipment inspection, right? So we're looking at the traction lines and looking at these specific 9 use cases. I talked to you a little bit about them in detail in the next semester. We are now using a small vehicle called a multi-corporate to do data acquisition, but we will move to a bigger aircraft. This is a fixed wing hybrid, which you will see a demo of outside when we leave, right? The camera that you're packing in this has a dual sensor, which means we do RGB. You will make the same. Next slide. We then look at all the 9 use cases, classified sub-faults in those 9 use cases, then did a manual inspection of how does the radius to base solve for it, looked for the gaps, and then came up with how can a drone sort of work in this scenario. And then we spent a lot of time with RDS in Lucknow, and we started doing a lot of data acquisition. So we continued spending a lot of time. So this is an actual OC inspection card that I was a part of, where we went and looked at how the maintenance happens today, and how can we use a drone to sort of automate the whole process. And with this understanding, we then went into the data. And again, there are other use cases, so we started collecting samples from cantilever health, missing number plates, dropper issues, etc. Right? This is an image of our drone flying at the Egmore yard here. Again, thanks to Southern Railways for allowing us to do this. And you can see a video of where the locomotive is moving and we're looking at a turnout. Turnout inspection is so critical because you have 2 wires coming on top and the gap between them is 50 mm. So you need to continue maintaining 50 mm. That's what we're trying to do. Next slide. Yeah, that video was from the drone itself. This is a sample of the model that we've done. We started already being able to detect burness on top of mass, right? And also we started looking for the temperature rise in the OHC components. These 2 are models that are built. We're now scaling this up, next slide, to include assets of the track and signaling, right? There are 22 use cases that are now being discussed. Thank you. Next slide. Thank you so much.
சுத்தம் ரொம்ப நல்லா இருக்கு. Energy that I just can't describe it. Second member. Let's make it a success. Let's be very, very focused on the quality, focused on safety, focused on how do we scale this try to be as much very much energy we have, then you must really get the benefit of this energy. He is very energetic leader. So, and a good, dynamic, future-looking. He is looking at the future of Tamil Nadu. So, look at that. Make sure that you get the benefit of his leadership. Thank you, friends. Thank you.
சார் என்ன சார் நீ மட்டும் ஓடிக்கிட்டே இருக்கீங்க சார் இப்படி வாங்க சார். சார் அங்க உள்ள போகாதீங்க, வெளியே போகாதீங்க.
So this takes off vertically, then moves horizontally. You do very short. You will not be able to actually do the wing mode. It can be
பழைய இடம் உள்ள இவங்க சைட் சைட் மண்ணடி உள்ள யாரும் மாட்டான் கத்தரிக்கவும் கலக்கவும்
அவ்வளோதான் கலர் பார் போட்டாச்சு வேலை முடிச்சாச்சு
அவ்வளோதான் சார்
இதுக்கு மேலே எதுவும் பண்ண முடியாது
வேல்முருகன் சார் சார் வாங்க சார் வேல்முருகன் சார் இங்கே வாங்க சார்
ஆமாம் சார்
நம்ம சைடில் நின்றுக்குவோம்
ஆமாம் சார் நான் ஓகே நீங்கள் கிளம்புறீங்க
வெளியே வந்துருச்சு சார் இது
ஓகே
அவன் சொல்லிட்டு லைட்டாக உள்ளே எழுதிட்டு விடுவோம்
ग्रुप फोटो ग्रुप फोटो
ना
சரி
जब हम विकसित भारत की बात करते हैं विकसित भारत
அடுத்து யார போறாங்க வரல
ஆங்கில கேள்விக்கு பண்ணி செவன்
இவங்க மறுபடியும் ஏனே போனாலும் மொத்தமாக போட்டுட்டு இருப்பானுங்க
டிஸ்கவுண்ட் நம்ம
நம்ம எடுக்கிறோமா
போகலாம் கொஞ்சம் லெவிடேஷன் மேக்னெட்டிக் லெவிடேஷன் வச்சா 400 km/h அதே மாதிரி இது ஃபுல் ஸ்பீடு வச்சா அந்த வேக்யூமில் வச்சா 600 km/h மட்டும் போகலாம். இன்னைக்கு எல்லாத்தையும் இன்னைக்கு டெமான்ஸ்ட்ரேட் பண்ணியிருக்கோம். இதை இப்போ வந்து டியூபுக்குள்ள ஒரு ரயில் வண்டி டெமான்ஸ்ட்ரேட் பண்ணியிருக்கோம், வெளியில லெவிடேஷன் பண்ணியிருக்கோம். அதெல்லாம் வந்து இப்போ இன்னும் ஒரு 2-3 மாசங்கள்ல இதை வந்து கம்ப்ளீட்டா டெமான்ஸ்ட்ரேஷனை முடிப்போம். இப்போ 410 km இருக்கு, அது 450 km ட்ராக் போட்டு இதை முடிப்போம். அது வந்து உலகத்திலேயே லாங்கஸ்ட் ட்ராக்காக இருக்கும். அதுக்கு அடுத்தது வந்து இது கமர்ஷியல் ஸ்கேலில் முதல்ல கார்கோவுக்கு ஆரம்பிப்போம், அடுத்தது வந்து ஃபுல் டிராஃபிக்.
இன்னைக்கு பார்க்கும்பொழுது ரொம்ப சந்தோஷப்பட்டாரு, பெரிய விஷயம்னு சொல்லி ரொம்ப ஆச்சரியப்பட்டாரு, நிறைய சப்போர்ட் பண்றோம்னு சொல்லியிருக்காரு.
ஆமா,
நம்ம
இப்போ கிட்டத்தட்ட 20 கோடி ரூபாய் மட்டும் ரயில்வேஸ்ல கொடுத்துருக்காங்க. மிச்சம் நிறைய பேர் நிறைய பணம் கொடுத்துருக்காங்க. இப்போ இன்னும் பல நமக்கு ரயில்வேஸ்லேருந்து நிறைய ஹெல்ப் இன்னைக்கு சொல்லியிருக்காங்க. குறிப்பாக இதோட எலக்ட்ரானிக்ஸ் மேனுஃபேக்சரிங் எல்லாத்துக்குமே நம்ம சேர்ந்து செய்யலாம்னு சொல்லியிருக்காரு. ரொம்ப சந்தோஷமாக